Okay, so this is limits day 2 indeterminate form. The indeterminate form is when you have a 0 in your numerator and denominator. So if we look at our function g of x over here, if you sub in a 3, you get 3 squared minus 6 times 3 plus 9 over 3 minus 3. That will give you 0 in your numerator, 0 in the denominator, which is indeterminate. So substitution, the direct sub is not going to work in this case. So thinking back to algebra, when you plug a number into an equation and you got 0, we called that number a root. Now when we get 0 over 0, that means our numerator and denominator share a root. In this case, we then factor the numerator to find that root and reduce. When we solve this problem, we get the predicted answer. So we're going to use some algebra here, and we're going to say g of x, factor your numerator, it's x minus 3 times x minus 3 over x minus 3. Okay, so we have this common factor of x minus 3 in the numerator and denominator. That tells us we have a whole at x equals 3. So now our function simplifies to be g of x equals x minus 3. So our limit, now let's do the limit of that. Limit as x approaches 3 of g of x, which is x minus 3, is going to be 3 minus 3, which equals 0. So we get 0 as our answer. You're not always going to get 0 as the answer, but in this one we did. So where the numerator and denominator have the limit 0 as x approaches a certain number, it's called a limit with an indeterminate form of 0 over 0. Limits with an indeterminate form 0 over 0 can quite often be found by using algebraic simplification. There's other indeterminate forms other than 0 over 0. You can have 0 to the 0, 1 to the infinity, infinity minus infinity, infinity over infinity, 0 times infinity, or infinity to the 0 power. Those would all also be considered indeterminate forms. So when you get that, you're going to simplify and try again. So let's look at this first example on the next page. Now, notation's important in these questions. What you're going to want to do is keep writing the limit as x approaches whatever number it is until you sub in the actual number. I'm just going to put c instead of a number. Until you sub in. So while I'm simplifying, I'm going to write limit as x approaches negative 7. I'm going to factor my numerator, x plus 7, x minus 3, over x plus 7. X plus 7s are going to cancel out. So this is going to be limit as x approaches negative 7 of x minus 3. Now I can substitute in the negative 7, and now that I substituted that in, do not write limit anymore. And our answer is going to be negative 10. Okay, number 2. Factor our numerator, limit as x approaches 2. That's going to be x minus 2 times x plus 2 over x minus 2. Cancel out those x minus 2's. That's going to be limit as x approaches 2 of x plus 2. And that's going to equal 2 plus 2, which is 4. Quick math, right? All right, this next one, we're going to want to simplify that complex fraction first. So let's multiply everything by our LCD. And the LCD in this one's going to be 3 times 3 plus h. Put that h over 1. Okay, so 3 times 3 plus h. 3 times 3 plus h. Okay, so this is going to be our limit as h approaches 0 of, first term's going to be 3. This is going to be minus, be careful, put parentheses around that 3 plus h. And the denominator is going to be 3h times 3 plus h. Okay, so we got to remember to distribute that negative sign right there. Still writing limit as h approaches 0. This is going to be, that's a negative 3 and a negative h. So the 3's cancel, it's just going to be negative h over 3h times 3 plus h. Okay, now I can simplify that. Cross out the h's, limit as h approaches 0. Numerator is going to be negative 1. Denominator is going to be 3 times 3 plus h. And at this point, now I'm subbing in the h, so I'm not going to, the h equals 0. So I'm not going to write limit anymore. And that's going to be negative 1/9. Okay, number 4. If you sub in 4, you're going to get 0 over 0 in determinant form. So try to rationalize that denominator. Multiply both the numerator and denominator by the conjugate here. Okay, and then keep that numerator in factored form. Don't multiply that out. That's going to make your life harder. The denominator, when you multiply that, you don't want to multiply out. That's going to be x. Middle terms cancel since it's a conjugate, x minus 4, which is great because those factors cancel. We're going to have limit as x approaches 2 of radical 2. Oh, no, I don't want to write that yet. Radical x plus 2. Let me fix that. That was as x approaches 4, not 2. So that's going to be radical 4 plus 2, which is 2 plus 2, 4 again. Great. Okay, so that's the main gist of that. The next couple sheets are just practice problems, so I'll do those out. So keep listening if you would like. All right, so we got limit as x approaches 1, factor your numerator. That's going to factor into 2x plus 3 times x minus 1. This is a good time to, pause the video and try the problem and then play it again, and you can fast forward through what I'm saying. Limit as x approaches 1 of 2x plus 3. 2 times 1 plus 3. So we're going to get 5 for that. All right, limit as x approaches negative 5, factor our numerator, x plus 5 times x minus 2, denominator, x plus 5 times x minus 5. Simplify. And now we're going to sub in negative 5, so we drop writing the limit. Negative 7 over negative 10, which is 7 over 10. Okay, 3, we have a difference of 2 cubes here. So this is going to be our limit as x approaches 2. We got x minus 2, same side, same sign, opposite. Remember, SOAP, same opposite, always positive. right there. We got x minus 2 in the denominator. So limit as x approaches 2 of x squared plus 2x plus 4. 2 squared plus 2 times 2 plus 4, which is going to give us 12. All right, number 4. Ooh, okay, this one's tricky. I'm going to put a star next to it. At first glance, it looks like you're going to factor by grouping the numerator, but that doesn't work. So what I did is, most likely there's going to be an x minus 3 somewhere in your numerator. So you'd actually have to factor that using synthetic division. I'm going to go up to the top here, see if I have some room. Okay, so the top was x cubed plus 2x squared minus 5x minus 6. The bottom was x plus 3. So if x plus 3 was a factor, then negative 3 would be solution. I'm going to factor this using synthetic division. You can use long division too if you'd like. Negative 3, negative 1, 3, negative 2, 6. Okay, great. That went in evenly. That means that the factors of your numerator were x plus 3, that solution right here, and then x squared minus x minus 2, which actually that is really nice because this factors into x minus 2 and x plus 1. Okay, so numerator, limit as x approaches negative 3. X plus 3 times x minus 2 times x plus 1 over x plus 3. All right, simplify that. Limit as x approaches negative 3 of x minus 2 times x plus 1. That's going to be negative 3 minus 2 times negative 3 plus 1. Do that out, you're going to get 10. Okay, number 5, numerator, it looks like I'm going to have to factor it at least twice. So let me just do that up here real quick. You could take out an x, the GCF there, x squared minus 3x plus 2. And then we got x minus 2, x minus 1. All right. Denominator, you just take a GCF out of that, so I'll do that as I do the problem. Limit as x approaches 0 of x times x minus 2 times x minus 1 over x times x minus 3. Okay, so our x's, we can reduce that as x approaches 0. X minus 2 times x minus 1 over x minus 3. Okay, so now we're going to plug in 0, 0 minus 2, 0 minus 1 over 0 minus 3. So that's negative 2 times negative 1 over negative 3. That's going to be 2/3. Okay, last one on this page. Not too bad at factoring. That's going to factor into x minus 4, x minus 2, x plus 4, x minus 1 in the denominator. All right, nothing cancels, so we're just going to plug in 4. We probably could have just plugged it in right from the beginning. This might not have even given us an indeterminate form. 4 plus 4. Okay, so that's going to give us 0 times negative 2 over 8 times 3. Okay, so that's 0 over 24, which is just going to equal 0. All right, last page of the notes. So this looks like some problems that have like complex fractions and radicals in it. So we're going to rationalize our numerator here. multiply by the conjugate. Okay, but we're going to keep our denominator factored out. Numerator is going to end up being x plus 2. Middle terms again are going to cancel, so minus 9. This is going to be x minus 7 times radical x plus 2 plus 3. It's going to be x minus 7 over x minus 7 radical x plus 2 plus 3. Oh, I don't want to forget to write limit. Cancel that. Limit as x approaches 7 of 1 over radical x plus 2 plus 3. That's going to be 1 over radical 7 plus 2 plus 3. So 1 over 6. Okay, another rationalizing. This time we're rationalizing the denominator. So limit as x approaches 4 of x minus 4 times radical x plus 2. Denominator turns out to be x minus 4. Great. That cancels. X plus 2. Okay, direct sub now. It's going to be radical 4 plus 2. So that's 2 plus 2, 4. Got that answer a lot today. All right, next problem. I'm going to make each of these a fraction. So it's a complex fraction. LCD is x. So I'm just going to multiply everything by x. And we'll have the limit as x approaches 2 of x plus 2 minus 2x over. And again, I'm going to keep this in factored form because hopefully something's going to cancel out. X minus 2. Okay, so this numerator over here is negative x plus 2. I can actually write that as negative 1 times x minus 2. Would be the best way to write it out so we can see what cancels. So it's going to be negative 1 times x minus 2 over x times x minus 2. X minus 2's cancel. Limit as x approaches 2 of negative 1 over x. Now I'm going to direct sub negative 1/2. All right, another complex fraction. Put that over 1, put that over 1. Least common denominator is just x plus 1. So we'll have our limit as x approaches 1 of 2x minus x plus 1. We don't want to forget to distribute that negative sign. Leave this as these two factors, x minus 1, x plus 1. It's going to be negative x minus 1. So limit as x approaches 1 of x minus 1 over x minus 1, x plus 1. Limit as x approaches 1 of 1 over x plus 1. 1 over 1 plus 1, so 1/2. All right, last couple. All right, again, looks like an indeterminate form if we were to sub in. So multiply by that conjugate, try to rationalize either your numerator or denominator, whichever one has the radical in it. Nine plus x minus 9 in your numerator, x times radical 9 plus x plus 3. All right, so numerator just simplifies to be x. All right, x's cancel, limit as x approaches 0, 1 over radical 9 plus x plus 3, that's going to be 1 over radical 9 plus 0 plus 3. All right, so that's 1 over 3 plus 3. And we get 1/6. Okay, last one. Again with the rationalizing, we're going to rationalize that numerator. Or no, rationalize the denominator. Did a lot of that last chapter, and you guys were good at that. All right, limit as x approaches 2. I'm going to leave this as x minus 2 times radical x plus 2 over x plus 2 minus 4. So x minus 2 times radical x plus 2 plus 2. Got to write that limit out in front still. All right, reduce, limit as x approaches 2. Radical x plus 2, that's going to equal radical 2 plus 2 plus 2. A lot of 2's there. All right, radical 4 plus 2, 2 plus 2, 4. Again. All right, that's it. So that's simplifying algebraically.